This video is going to cover a couple of different topics related to graphing. So we're going to start with the distance formula. So to find the distance between any 2 points on a graph, we can essentially use Pythagorean theorem. By drawing a horizontal line and a vertical line, then we can create a right triangle, and then we can use Pythagorean theorem from there. So the lengths of the sides, or the legs, as the change in the x value and the change in the y value, the absolute value of that, because it's a distance, so it's positive. And then the thing that we're looking for is the hypotenuse. So using Pythagorean theorem, we're picking the positive version of the radical that would result when taking a square root. And there we have our distance formula. So the distance between any 2 points is the square root of the difference in the x's squared plus the difference in the y's squared. And then again, we're using the principal square root, so the positive version of the radical. And since we're squaring those differences, then it really doesn't matter what order we put them in, because we're always going to get something back that's positive. So we want to find the distance between these 2 points, and we want to put our answer in simplified radical form as well as a rounded form. So again, since order doesn't matter here, I'm going to just plug in my x's going left to right. So I would do -1 minus 3 squared plus 4 minus -2 squared, all of that under the radical. And so when you type this into a calculator, since we want the simplified radical version, don't start by putting in the radical, just do the stuff underneath. And in this case, we get radical 52 or root 52. And so we want to put this in simplified form. So we do need to check to see, are there any perfect squares that go into 52? And the answer is yes. We can divide 52 by 4 and we get 13 back. So our simplified radical form would be 2 radical 13. This answer would also be considered the exact form. So if you ever asked to give your answer as an exact answer, this would be it. We're not losing any decimal places. If you plug this into your calculator, we get a value of about 7.21. So that would be our answer rounded to 2 decimal places. Next, we have the midpoint formula. So this is finding the middle between 2 coordinates, both in the x and y's. So if we have a line segment who has a certain endpoints, the coordinates would be, so we're going to average the parts essentially, x1 plus x2 over 2, and then y1 plus y2 over 2. So let's say we have these 2 points as endpoints for a segment. To find the midpoint, we're going to add together the x's, at 1 plus -8 over 2. We're going to add together the y's, -6 plus -4 divided by 2. 1 plus -8 is -7. We cannot divide that evenly, so we just leave it as a fraction of -7 over 2. -6 plus -4 is -10. Divide that by 2, we get -5. So the last topic we're going to look at is circles. So we've got the formal geometric definition here. A circle is a set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle center to any point on the circle is called the radius. So when we're trying to find the equation of a circle, we can, again, essentially just use the distance formula, right? Because we've got the distance between our center and any point on the circle is our radius. So the radius is the distance between those 2 points. And so again, we're just plugging it into the distance formula and we get our value there. But we don't usually like to have a radical in a formula. So by squaring both sides, we get the standard form. So the standard form of the equation of a circle is going to have center hk and radius r. We've got the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. Now, something to always be careful with here. Notice in this standard form, in the equation itself, we're subtracting our center and radius. So just be aware. I always like to say the signs are going to be opposite. So if it says x minus a number, your center point would be at the positive version of that number. Okay. The other thing to consider as well is that in our standard form, the equation has it being r squared. So our radius is just r. So if we're coming from the equation, we have to make sure to take the square root. So let's say we're supposed to write the equation. We've got a center of -2, 3 and a radius of 4. So we're just going to plug the pieces in. So I'll have x minus the x coordinate, which is -2. That quantity is being squared plus y minus the y coordinate, which is 3. That quantity is being squared is equal to my radius, which is 4, and that's being squared as well. So just to clean this up a little bit, this would turn into x plus 2 squared plus y minus 3 squared is equal to 16. So working backwards, let's say we have the equation, we want to find the center and the radius. So we've got the quantity x minus 2 squared plus the quantity y plus 4 squared being equal to 9. So our center, again, we're going to take the opposite sign of what's in our parentheses. So if it's x minus 2, our x coordinate is a positive 2. And since it's y plus 4, our y coordinate would be a negative 4. Our radius, we're going to take the square root of 9 to get 3. Now, in order to graph that, we're going to start with the center. So our center here is at 2, negative 4. And then we're going to use the radius. So again, the radius tells us the distance from the center to any point. Now, the actual points on the circle are a little challenging, but we do have nice, easy distances we can follow, which are vertical and horizontal. So what I usually do is I start with my center, I use my radius of 3, and I can put a point up 1, 2, 3, down 1, 2, 3, left 1, 2, 3, and right 1, 2, 3, and then connect my points to make as good of a circle as I can. Now, we're supposed to use this graph to identify the function's domain and range. Sorry, not a function. It does not pass the vertical line test. It is just a relation. We're supposed to identify the relation's domain and range. So anytime we're thinking domain, we're thinking the x values from smallest to largest. So the smallest x value in this circle is negative 1. The biggest x value at the circle is 5. And both of those coordinates exist, so we're going to have the square brackets. You could actually figure those out without graphing, with our idea that we want up, down, left, and right. So by going right and by going left, we've either added 3 or subtracted 3. So you could do our center coordinate 2 plus or minus 3 to get those values. Similarly with the range, we can look at our smallest y value, which is negative 7, and our biggest y value is negative 1. Again, those points are included. And same idea, if I take my negative 4 and I do plus or minus my radius of 3, that's how we can get those values. So not only do we have standard form for a circle, we also have the general form. But like most general forms, it's not really useful on its own. It's just a different way we can write it. So our general form here has our quantities being expanded out and set equal to 0. So on its own, it's not really useful. So what we're going to do is we're going to convert this back into standard form. And so the question becomes, how do we do this? We're going to be completing the square on both x and y. So we're going to complete the square twice because our standard form has those two perfect squares for the x and the y's. So we need to write in standard form. We've got x squared plus y squared plus 4x minus 6y minus 23 equals 0. So I'm going to kind of do two steps at once here. The first thing I'm going to do is I'm going to rearrange my ordering of my equation so that my x's are grouped together and my y's are grouped together. So I'm going to have x squared plus 4x, and then I'm going to leave myself some space because that's where I'm going to do my completing the square step. I'll have my y's grouped together, so plus y squared minus 6y. I'm going to leave myself some space, and here's where I'm going to do my second step, which is to move my constant to the other side. So in this case, we're going to add the 23. All right, so completing the square. If you don't remember how to do it, you start by taking the b values. That's your coefficient in front of your linear term. So in this case, I'm starting with x's, so the coefficient in front of x is 4. We're going to divide that number in half. 4 divided by 2 is 2. And then we're going to square that number. So 2 squared is 4. So by adding 4, I've actually created something that's a perfect square trinomial. But what I've done now is I've made my equation unbalanced. I've added something to one side, but not the other side. So it's not equal anymore. So to maintain the equality, if I add something to one side, I also have to add it to the other side. We're going to do the same thing then with the y's. The b term for the y's is negative 6. Divide that in half, we get negative 3. and then we square that to get 9. So we can add 9 to both sides to create the perfect square there. So now we're going to write this in the perfect squared form. So the two numbers that multiply to get to 4 and add to get to 4 are 2 and 2. And so what actually happens every time is that this number here is always going to be your b over 2 term. Plus two numbers that multiply to get to 9 and add to get to -6 are -3 and -3. So that quantity is squared. And again, that number there is going to be the same as its b over 2 term. Well, now this is equal to 23 plus 4 is 27, plus another 9 is 36. And now we have it in standard form. We're not going to graph, but we can at least figure out what's our center and radius. So center, again, we're going to use the opposite sign. It's x plus 2. So our x coordinate is actually going to be -2. And it's y minus 3. So our y coordinate is going to be +3. This is equal to our r squared. So r squared is 36, which means we have to take the square root to get our r value of 6.